Hi, welcome to Edu4Sure online trainings. Today we're going to discuss about normalization in SQL Server, and this is most important topics like uh, so. I'm sorry. So this is the most important topic. Like whenever you're working with tables in the database in DBMS, that if and only if the tables they satisfy this 1NF, 2NF, and 3NF, at least till 3NF, only then the tables are it will be free from a few anomalies, right? So before we get into this normalization and the normal forms we have, so normalization is nothing but it is a process of reducing the data redundancy, okay? And normalizations clears the anomalies as in confusions. Whenever we are inserting a data into a table, whenever we update data into a table, update the data in the table, whenever we delete data from the table. So if at all a table is not normalized, so what are all the challenges can we face? So challenges as in disturbances or confusions. So to better understand normalization, first let us understand what are these anomalies and how these anomalies can be avoided. What is the way where we can avoid these anomalies? So this is the dummy script. So just look into this script. So I have come up. I have I'm sorry. So this is a dummy script where what is that we are doing over here? We are creating a table named student underscore admission and the student. So these are the columns. So also called as attributes. So these columns, what are all the columns have we got in student underscore admission table? So the very first one is student roll number. This is of type int, and I have deployed identity function on top of this column, student roll number column of student admission table. And the next one is student name, which is of type string, and it accepts at most 50 characters, not more than that, and followed by student DOB, date of birth, day of time, date time, and next comes branch ID. So say whenever a student gets admitted into a college or into a school or into his graduation, so he will be enrolling for some or other courses, right? So branch ID is all about the course he's enrolled for, and branch description is all about the full form of the branch ID. If he's into MCA, obviously MCA stands for Master of Computer Applications, and if he's into MBA, it stands for Master of Business Administration. If it is BSc, Bachelor of Science, and if it is BCom, it is Bachelor of Commerce, likewise. And finally, it's the faculty name who deals these courses, right? So I understand. I know that not a single faculty is the entire course, but to make things simple, so this is example, right? So just don't take the example seriously, but try to understand the concept. So now I'm coming up with some insert scripts, right? So you can execute this create table and insert scripts at your end, and then click on this statement, select the statement. What is the statement? To retrieve data from a table, it is select star from the table name. Here in our case, the table name is students underscore admission. Click on this and see, you're able to see the data over here. What is it we are doing? In the student admissions table, what are all the columns have we got? Student roll number. If at all we are giving student roll number, what all can we get? We can get the student name, student DOB, branch ID, branch description, faculty name. So if you can closely observe, if at all we pass on student roll number, what is that we gonna get? Student name is directly related on the student roll number, right? Like as in when a student is gets admitted into a college and he enrolls for a course, he will be given some roll number, right? So as to uniquely identify. So that is what we are doing over here, the student roll number. If I have the student roll number with me, can I get the student name and his student details, like student address, student phone number, and everything? Yes, I can. Why? Because student roll number is unique, which uh, uniquely identifies the records in student table. So apart from that, what else I have got in the student admission table? I've got branch ID, branch description, and faculty name. Say, so Vijay Pandar is the first student who got enrolled to the branch MCA, Master of Computer Applications, and the faculty name is Jayant. So there is another guy, Dinesh Sankepalli. Okay. and we are also capturing the date of birth, student's date of birth. So, and he has enrolled for Master of Business Administration. Okay, and oh, I'm sorry. Oh, I am sorry. Okay, update student admission set faculty name where student. Okay. So MBA is so I'll copy paste this instead of updating it over here. You don't need this. Okay, so if you run this, so yeah, in this college, say this is some college, and in this college we have got 4 courses: MCA, MBA, BSc, and BCom. Right? These are the 4 courses. Like as and when student comes and enrolls for a course, only then the record gets inserted into this table. Just assume that as and when a student comes to the college and he enrolls for a course, the records gets inserted into this table. So firstly, it was Vijay Bandari and followed by Dinesh Sankarpalli, and these 2 people, they have enrolled for 2 different courses, MCA and MBA. Likewise, next comes Durga Valepu, Raghav Chari. They have enrolled for MCA, followed by Usha Kantiti on MBA. And there was another guy, Achitanand, who joined the college and enrolled for course BCom. Okay, Bachelor of Commerce. So what is that it is happening? If you can take a closer look into this table, what is that? The data is repeating, right? What is the data? What is that it is repeating? Student roll number. Do you think student roll number is repeating? No. As in when a new student comes, a roll number is being allotted. Student name, is that repeating? No. Student DOB, chances. It cannot. It is like we cannot assure that two students can be born on same day. It is purely normal. What is that it is repeating? If you can see, if you can look into the branch ID, branch description, and faculty name, don't you think this data is repeating each and every time a student is getting enrolled to MCA? Say, suppose, okay, let's do one thing. I'll filter it with the course, branch ID or course, okay, where branch ID is equal to MCA, okay. Likewise, form PSC MBA. Let me run these queries individually and see. So there are 4 people who enrolled for MCA, 3 people who enrolled for MBA course, and 3 people who enrolled for BSc, and only 1 guy who enrolled for BCom. So when does the record end? When do we insert a record into the student admission table? Only when the student enrolls for the course. Okay. If the student is not enrolling for the course, we don't enter any record. So case 1, insertion anomaly. So now what is an anomaly? Anomaly is nothing but confusion. Now, and how many types of anomalies? 3 types of anomalies. What are they? Insertion anomaly, updation anomaly, deletion anomaly. So let us look into these anomalies one by one. And if you can see, so this what is that it is repeating over here? If at all we are running this select star from admission, and if I filter it and we are getting only records based on the branch IDs, what is that it is repeating over here? Branch ID, branch description, and faculty name is the one which is repeating. If at all a new guy comes, again, say suppose there is another guy who's coming and who's enrolling for some what do you say, again, and his name is Divya Bandari, and 1992. Okay. What is that? Every time a new guy comes and jumps in, it is like we are repeating the data. So isn't it the waste of time? We're just wasting time in coming up with some extra data, which is not needed actually. Okay. And say suppose that's about insertion anomaly. Okay. Say suppose we want to insert a record into this table, so we can straight away insert student roll number, student name, and student DB. Why do we really need to enter the same data again and again? Like say if 100 more students are coming, it is like we need to enter the branch ID, brand description, and faculty name 100 more times. Some in this example I have considered only 3 columns: branch ID, description, and faculty name. Possibility there can be a number of, like I can go like branch incorporated date, okay, and branch expiry date. So there can be a number of fields which is related to branch itself. So it isn't, don't you think this is an overburden whenever a new guy is coming and he's enrolling for the existing courses? And besides the student information, we are also capturing some extra information, and that extra information is keep on repeating each and every time. Okay, so this is the problem with insertion anomaly. And if you can look into this updation anomaly, so what is that we wanted to, okay, fine. So let us look into the deletion anomaly first. So what is that confusion have we got with the deletion anomaly? So let me run without filtering the data. Let me run, and just see what is all that we have got in student underscore admission table. So there is only one guy who enrolled for BCom, right? Say this guy is no more interested, and he's interested, and he just got enrolled, and we have created an entry into this table. Now he's absconding. What if he's absconding? Like he's interested in some other college, so he left this college and he moved to some other college. So do you think we really need this record? We don't need this record actually. Okay, so can I delete this record? Yes, you can delete this record. Okay, so don't get confused with the transaction begin, tran, rollback, and commit. This is for your understanding, and we do have a clear and crystal clear videos on transactions in SQL Server and asset properties. Please go through them as a prerequisite, and then you can come back and take a look into this example. Now what I'll do is delete from student admission table where student roll number is equal to what, 6. So this guy is no more available, no more visits, no more attends the college. Okay, Achyutanan, and he got enrolled for course BCom. So what I wanted to do, I just wanted to take out the record of Achyutanan. Okay, but if you can see, this college has got 4 courses. MCA, MBA, BSc, and BCom. Okay. So I just wanted to do delete this guy's information from the database. So let me delete this, and let us see what is that it had happened. If I delete that, yeah, we're only left out with 10 records. Earlier it was 11 records. We don't see the student roll number with 6, but what actually had happened? Why did we delete the branch ID, which is of BCom? See, a student, many number of students can depend on branch, but branch never depends on a student. So you got my point. What I'm trying to say is one student can enroll for one branch. Likewise, many students can also choose one branch, but a branch don't chooses the student. It is the student who is interested and who chooses and who wants to pursue a career in one particular branch. He chooses the branch. Okay, but like here, whenever we are deleting a student from student admission table, what is that we are missing here? We are also losing the data of branch details. So actually in that particular college we have got 4 branches, but with the delete of that student record, the branch information is also lost. So this is deletion anomaly. So which means Initially we thought this would do the job, this table, this information, maintaining the information in this way would do the job, but this is not doing the job. With maintaining information in this way leads to data repetition, which is nothing but data redundancy and deletion anomaly. When I say data redundancy, that's an initial insertion anomaly. When I say data deletion anomaly, I say loss of data. With the delete of student information, the corresponding branch information is also getting deleted. It doesn't mean, if you can take a look into this table now, what all we are left with: MCA, MBA, and BSc. But these are not the only courses that are available in the course in the college. We've got MCA, MBA, BSc, and BCom too. So that was the only guy. But and what is the other challenge we have got? Until and unless a student is enrolled, we don't insert that record. See, we can't straight away insert a record into this table just like that. Say suppose he's not enrolled for this course, so a student has come, he got admitted into the college, but he is not enrolled to any of the courses. Then is it possible for me to enter information, or to maintain the information, to enter that particular student details into this table? No, because he's not enrolled. Until and unless he enrolls for a course, the entry is not possible into this table. So that's an insertion anomaly. So, okay, now hope we are clear with insertion and deletion anomaly. What is updation anomaly? Okay, say after some few months, Jayant, faculty named Jayant, who deals with MCA, okay, he's done with the college and he left the college. He's retired from his job, from his roles and responsibilities, and a new guy has come in place of Jayant. Okay, so Jayant, faculty of MCA, Jayant is replaced by Vikrant. Okay, he's a new faculty guy who just joined the college to mentor, to teach MCA, right? So what is that happening now? MCA is dealt by only a single guy, and he's moved out of the college, and a new guy Vikrant has come into his place. So what is that happened? One change. It was literally a single change. But if you want to update, what is that you need to do? You need to update all the records. Each and every records need to be updated. Like Jayant, the faculty name Jayant, like we do capture the student information and the branch information and the faculty name as well. So a single change can be done, but what is that we are doing? As we have got multiple records in this table, we need to update, we need to replace Jayant with Vikrant at different places. It is not a single change, but it is impacting us in a different way at different places. So this is what we call updation anomaly. So can we overcome this? Do we have any process or something in place so that we can overcome this? Yes. And that process is called normalization. Well, normalization is nothing but process of reducing the data redundancy. What is the data that is being redundant in this table? Here, these three columns are redundant. Irrespective of the student who enrolls for the course, this data is keep on coming again and again and again. See, as of now, we have only 10 students got enrolled in our college, and they have chosen some subjects as their courses. What if the table goes on and it increases up to 500 and 1,000 or some 3,000 or 4,000? This data is being iterative, and this is being redundant. I mean, it's repeating, right? So what we'll do is can we do it this way? I mean, we need to do something wherein we don't find any problem at the time of insertion, at the time of deletion, and at the time of updation. Okay, so can we do it this way? I just wanted to divide this table in another way. Okay, what I'll do is, student, so let's start from student admission. So into don't go with examples like normalization. Though normalization starts first, it would be better for you to first go to the ways to insert data into a database, into database tables. And you also need to go take a look into the transactions. Okay, this was deleted. Okay, I'm rolling back this. Roll back as in whatever the data we have deleted from the table, student roll number 6 will be rolled back, which means that won't be affected in the database. So that is what rollback mean by. And we have got two commands. If we are sure, if we surely want to delete the data, and after passing that command, if at all we are, see, by default SQL Server is in auto commit mode. Whatever the command you give, DML, update, insert, or delete, those will be affected immediately, and the changes are returned to the database. And if at all you're opening any transaction by chance, the transaction will be open, which means you can do a number of operations. It could be delete, update, delete, or insert. Okay, but these operations need to be I mean, we need to say things to the database, whether to commit or whether to roll back. So that is what I have did here. I don't want this delete to be performed on the student admission table for student roll number 6. So if you check, now you will be able to see the student roll number 6 over here back again, right? So BCom, it is back again here. So is there a way wherein I can stop this data redundancy and minimize? I can't stop, but I can minimize. Is there a way wherein I can minimize the data redundancy and clear this insertion, updation, and deletion anomalies? Yes, by making use of the normalization concept. So normalization is nothing but it is when you're asked what does a normalization do? Well, normalization is a process to minimize the data redundancy and to clear the insertion, updation, and deletion anomalies. So how do we do that? So let us see how do we do that in practical. So what I'll do is I'll make two tables out of the single table. Okay, and how do I do that? Let us see. Into students information, student info table. Okay. Student roll number, student name, student DOP, branch ID. This is what all I wanted in student info. And what is that I wanted in and branch info. Just making from this complex table, I'm just dividing the table into two tables, branch info and student info. So let me run these two commands and we'll see two tables will be created. See, if you want to check, we don't have any tables with the name student underscore info. How do we check that? Sys underscore objects. Go to student info. Run and see, like we don't have any object as of now. So let me run these two commands. See, two tables. OMG. I'm sorry. Okay. What is that we are doing? I don't want things to be repeated, so I'm just dropping that. Okay, and I'm re-executing this. Okay. So now let us see if the tables got created in the database or not. See, now you are able to see student underscore info. So how we, if at all you want to check, what is the way to check? To check for the tables or whatever the database objects you create in the database, SQL Server database, it is sys.objects in the name. If you're aware of the name, you can check for the name by using this command. So now let us see what is that I have done with these two tables. What is that? How did I decompose a single table into two? Okay, from student info. Select star from branch info. What all have I got? See, like I said, this college has got only 4 branches: BCom, BSc, MBA, and MCA, right? These are the faculty names. Now let us understand if you have actually stopped data redundancy and minimize the insertion anomaly, updation anomaly, and deletion anomaly. Did we really do that? Yes. How? What is that we have got in student info? It is simple. Now, as and when a student comes in and enrolls for a course, like he will be provided with student roll number. We also take his name and date of birth and the course he is enrolling for. So this is short, crisp. Okay, I'm no more maintaining the branch details, and so the data redundancy is minimal. We have minimized the data redundancy. We are not capturing branch description and we are not capturing a faculty name. So that redundant data has been minimized to the maximum. And what is that we are capturing in branch info? It is all about the courses and the faculties who deals with these courses straight away. Okay, now insertion anomaly. We have stop the data, redundant data. Like we have minimized the redundant data, we are only capturing branch ID. Why are we capturing branch ID? If at all you wanted to know what is MCA, you can join branch info table with that of student info table on the branch ID columns, and you can get the faculty name and the branch description, right? So that's the reason we are still maintaining branch ID in student info, and branch ID will be the parent key in branch info table as well. And this will be a foreign key in student info table. So let's talk about the deletion anomaly we have. Now, if Achyutanand, this guy, if he is no more, and if I delete this record, will this be affecting this branch info table? No. Why? Because branch related information is maintained in a separate table. Okay, and student information record is if this particular guy is absconding from the college, if he is no more attending the classes, and if I delete from student info where student roll number equal to 6. What is 6? He's enrolled for BCom. And where do I see that information? In select star from branch info. It's over here, BCom. If I delete this record from student info, will that be affecting this branch info table? The college still has the course BCom. It doesn't mean if at all a student is absconding, the course will be removed. See, we still have the record, but the deletion is smooth. We are no more maintaining the record. So we have cleared the deletion anomaly. There is no more confusion on deletion. And let's discuss about the updation anomaly. What is that updation? See, like I said, Jayant is done and he is moving out of the college. He is retired and he is moving out of the college. And who is Jayant? Well, Jayant is a faculty who deals with MCA. This guy. So he is being replaced by Vikrant. Okay. So if I want to update the faculty name, will I be updating the student info as well? No. What is that we have got in student info? It is only the branch ID, and the faculty name we got that information in branch info. So is it okay? So the change is single. So can I change it over here? Only this single thing. If I make changes in the single record, will that be applied to all the records in student information table, student info table? Yes. Let us see that as well. Update branch info set faculty name is equal to Vikrant, where branch ID is equal to MC. So let me run this command and see. Okay. Now, if you see earlier, what is that we have got for this particular record, Vijay Bandari, who is enrolled for MCA, the faculty is Jayant. Now let us see who's teaching for MCA and where the student enrolled for MCA and where the student roll number is 1. So let's start from student info, where Student roll number is equal to 1. Let's see. This is MCA and his branch ID is MCA. Okay. So let's start from branch info where branch ID is equal to MCA. With this, I'm gonna get the faculty name, right? See, it is Vikrant. So the change is simple and the updation anomaly is also cleared here in this case, right? Now we are clear with insertion, updation, and deletion anomaly, and we have reduced to the maximum, and we have reduced the data redundancy to the maximum. So this is called normalization, right? This is all about normalization. Now, how many normal forms have we got? Well, we have got around how many normal forms? We have got around 6 normal form. This first normal form, second normal form, third normal form, voice code normal form, fourth normal form, I'm sorry, let's come back to this. So fourth normal form, fifth normal form, last but not the least, sixth normal form. You can see it is important for each and every individual who's going through this course to understand the first 3 normal forms, because most of the projects today in real time, they hardly use these 3 normal forms. We don't go for voice code, and we don't even go for this. Though we have got these normal forms, but we never used these normal forms. It is so I'll be concentrating a lot on this first 3 normal forms. If you understand this, so it will be easy for you to whenever a table is provided to you, which is denormalized table. I mean, is provided to you like I have like we have seen here, student admission table. So you will be in a position to uh, make the table into this first 3 normal forms, and you can go ahead, and that is how you well. The point to be noted over here, like you don't need to be uh, you won't be designing the database architect, like you won't be taking a call and designing this table by like deciding the primary key, foreign key, and other constraints, and making sure the tables are in first to 1, 2, and 3NF. Okay, so it will be the job of database architect, who will be having experience, like he'll be having some years of experience, and it will be his call. And a small mistake in the database architecture will bring down the database, like we won't get the queries faster. So but it is much needed for you to understand how the what actually we do with 1NF, 2NF, and 3NF. When I say NF, it is a short form of normal form. So first normal form, also called as 1NF, likewise second 2NF, third 3NF. Okay. This can also be called as BCNF, voice code normal form, or 3.5NF. This is 4NF. This is 5NF. This is 6NF. Okay. Now let us see in detail what is this 1NF, 2NF, 3NF, 4NF. Let's see till here 3.5NF or BCNF. So what is first normal form? A table. So to understand that, let's come over here. Okay. Okay. What is 1NF? A table is said to be in 1NF. Okay. Just give me a minute. Let me open the notes, running notes. Okay. First normal form. Well, and we have got certain rules to let the table be in first normal form. What is that? See, look into this. It has to have atomic values. A table is said to be in 1NF only if it has got atomic values. Data types in the column should remain the same. No two columns should have the same. So if a table has got these three, so say let me create a sample table. Okay, create table 1NF. Okay, first normal form demo. What all we have got in this? So ID, name, age, and subject. ID, student ID, type in student name, varchar. What we'll do is varchar student DOB, date time, and subject course enrolled varchar of 10. Let me create this table, execute, and now as we already have the data in student admission table, let's start from student admission table. What is that we have got in student admission table? About 1, 2, and 3, and the course enrolled for is also is here. Okay, so I'll do one thing. I'll take these 3 records. So first 3 records. So first 5 records. I'll take first 5 records. So what is that you do if at all you want to take consider only first 5 records? You make use of the top 5, top and the number. Top 5 what? Student roll number. Okay. Student name. Student DOB. Okay, I want these 3. Got it? So what I'll do is I'll insert this records. This is how you prepare tables with dummy records. Like I told you, why do we insert records? See, in real time, you never create a table. You never insert data into the table. Everything will be from the front-end application only. Why is that now? Why is that we are creating and inserting data? This is uh, to create some dummy data and to work on the to work in a test environment. You need to create data on your own. So that is the reason I'm showing you on how to create tables on and how do we insert data into the table. So okay, insert into first NF demo, and these are the basics. One should be aware, one that if at all you want to become a database developer, and it is mandatory for you to understand these basics. So we are passing only 3 columns, but we have got 4. So what I'll do is I'll pass only 3 columns: student ID, student name, student DOB. Okay. So let me insert into this. Suppose we have got this table, okay, and update first NF demo, set course enrolled is equal to what is that is enrolling for? Suppose he is enrolling for both C and SQL Server. Okay, where student roll number is equal to 1. Records 5, 4, 2. Now student 2 is enrolling only for Java. Student 3 is enrolling again for .NET SQL Server. Student 4 is enrolling for SQL Server itself. Student 5 is for C#. Insert this data into this table, and okay, what is that? 10. Oh, okay, not a problem. What we'll do is, what is that? What does the statement mean by? See, the course enrolled, It at most accept 10 parameters, but what is that we have given here? More than 10 characters. How do we correct this? By altering. Alter table first NF demo, alter column. What is it? Course enrolled, varchar of 50. This is how we make changes to the data length. Okay, now execute all these 5 and it will be executed without any errors. Got it? Now let us see what is the data we have got in this first NF demo. Select star from first NF demo. Okay, so got this table. Vijay Bandari, student ID, student DUB and course enrollee. Vijay Bandari has enrolled for 2 courses, C and SQL Server. But what is the rule for a table to be in 1NF? To have atomic values, which means no single column should have multiple values. Okay, here we have got multiple values, right? So what would be the challenge? If at all, okay, don't get into the anomalies again, like we are clear with the anomalies. But the first rule is a single cell, which means this over here should not contain more than one value. So what is that we can do? What is that we need to do? We need to do this. So what I'll do is select star from first NF demo. Okay, and what is that it is saying? What are other? Let's get back to the rules and see and try to understand. No single value should have more than one value. That's the first one. To have atomic rules, data types in the column should remain same. What does it mean by student ID is of type int, right? No, I can't come here and I can say 6A or 6B. It should be the same. The data type should be the same, and we need to make sure the column names are different. We should not make use of the same column name again and again. This will be a confusion again. Okay, we need to avoid that. And the third one is no two columns should have the same name. I can't make use of the same. If I say ID over here, I can't use the ID again here, because this will create chaos. We shouldn't be creating chaos from our end. Okay, we should be clear. So one thing, number 3 is fine. No columns have got the same names. Data types in the column should remain same. Yes, data types are same. I don't get any like we are not mingling data types. Okay, int has got only numbers, student ID has got only numbers, name has got only characters, student DOB has got only date. So and course enroll has got only characters. But what is that we are having? A single cell with the multiple values. This if we work on this, then our table is set to be in first normal form, set to have satisfied first normal form rules, and it will be and that particular table first NF demo is set to be in first normal form. So how do you do that? So we can do this by select star from student first NF demo. Where student ID is equal to 1 union of, you don't get into this SQL statements. They are a bit confusing for you. I'm just making the data. Okay. So what I do is you need to clear the data. This is error cell. Now what I do is we don't want the data this way. Okay, what we need to do is each and every row should be unique. Every row should be unique. You need to keep that in your mind. The table is set to be in NF 1NF if each and every row should be unique. Okay, how can I get that? Like what is that I'm expecting over here? Okay, I'll copy this and I'll take this to the Excel. Okay. This is the data we have got. This is the sample data. Okay, closing this. So last. This is for better understanding. So this is what we have got the data in this way. But as per for 1NF rules, what is that we want? No single cell should have multiple values, right? These are the multiple values we have got in this table. So how can we get rid of them? Now, can you see now? Can I identify records like each and every cell has got only one record, right? See, one Vijay Bandari is enrolled for course. He is enrolled for two courses. This guy enrolled for two courses. Now, is this clear? And is it easy for like the data types? I mean, the data type is same in each and every column. Column names are not repeated, and each and every cell has got only one record, right? J Bandari, Vijay Sankapalli, each and every cell has got only one record. So, like, now the table is set up in 1NF. From this, we are working on the, we are looking into the rules and we are bringing out this. So now this table is set to be in normal form, 1NF. So what are the rules for a table to become in to satisfy what are the rules we have got for a table to be in 1NF? It should have atomic values, which means single values, no multiple values in a single cell. Data types in the column should remain same. Like I said, here student ID is of type int. I'm not expecting any integer. I'm not expecting any varchar here in between. Now suddenly I can't say ABC or something. Like we need to follow this. And third one is no column name should be repeated. Now this table is set to be in 1NF. Now see, now look into the 2NF. What is 2NF? No partial dependency. Okay. Let us understand what is this mean by. So we've got an example over here. Okay. What are the rules for a table to be in 2NF? Rules for a table in 2NF. First thing, it has to be in 1NF. And secondly, no partial dependency. So let us understand this too. What does like now? Hope you are clear. For a table to be in 2NF, it has to be in 1NF. For a table to be in 1NF, what is that? There should be no multiple values in single cell, no column names should be repeated, and no there shouldn't be any breach in the data types. What do we mean by that? Like if the student ID is of type int, they are expecting only numbers in that particular student ID column of the student first end of demo table. Okay. Yeah. So let's look into the example. Sorry for making you wait. So what is that we have got? Yeah, this is our example table. Okay. Say we have got a table with this information: student ID, student name, professor ID, professor name, and grade. So this table is in 1NF because data types are same and no column names are repeated, and every cell has got only one value. But what is that? Partial dependency. What does a partial dependency mean by? So student name, we can solely get the student name from student ID, right? Can we get the professor name from student ID? Can we? Or can we get the grade? Okay, what does partial dependency mean by? What is that we are doing here? We need to create primary key and foreign key relationship, parent and child table relationships. Like these here, student ID, I call it as these are the this is the primary key in this table. Say suppose I declare primary key on top of student ID. So when I say primary key, using that particular key, we are able to get all the records. We are able to get all the. We must be able to get all the records of that particular table. If I say, see, if select star from table where treat this table name as TBL, where student ID is equal to 1, then I'm able to get everything, right? Student ID uniquely identifies. And what if I say, if at all I'm getting multiple values, then there is some disturbance. Okay. What if I say, select star from TBL where professor ID is equal to 1? Will this be giving me a single record or a multiple records? I would get multiple records. Why? There are 2 records with professors, and I would get 2 different students who's being taught by the professor. So what is that we need to do? For a table to be into an F, every non-key attribute, I mean every other columns should be fully dependent on. Using this, when I say fully dependent, functional dependency, student ID should derive this. If I give student ID, I'm able to find out the student name, professor ID, professor name, grade. If I'm not able to do so, take out that extra, take out those columns which cannot derive, which cannot define by passing in the primary key. So take them and put them into, move them into different tables. So what is that we can do? Can I make 3 tables out of this? How? Like, okay, can I get professor ID? If at all I pass 3, will I be getting the student ID as 1? Because there is no relation between student and professor. A student can have 1 professor. Many students can have a single professor, but 1 professor can't have a single student. Student, like, okay, least bother about this grade. Okay, we'll take this out. You don't need that grade information table. You don't need this. So what I'm saying is we have got this table. So what is that can I can derive here? What is it I can do over here? Can I get professor name by giving the student ID? And will I be getting only 1 record? No. Why? Because this particular that professor has nothing to do with students, and student. See, this is some kind of one-to-many, many-to-one relationships. One student can enroll for 1 course. Okay, can enroll for n number of courses. Like we have seen in the last example, a student can enroll for C, and a student can also enroll for SQL Server. It means 2 different faculties might teach these 2 different subjects. So one student can have many faculties, but one faculty. Okay, likewise, we can't derive. If at all I'm giving this, I can't get the names of the students. Course will be taught by 1 professor, and he will be directly assigned to the course. but not to the student. Whereas student is not directly assigned to the professor, but he enrolls for the course, and whoever the faculty that teaches that particular course will be directly assigned again here. So what is that we are doing? So as to clear this, I mean, what are all the columns that are not directly dependent on this student ID need to be moved, and they have to be moved to a different table. So how can I do that? Can I do it this way? So I take out the students table and I put it aside, and I take out the professor details table and put it aside. Professor details, professor name. One is Raja Reddy, two is Sushmita, three is Brahma. Now it is clear. Yes, it is. Now, if I say Professor ID is 1, will I be getting more than one record? No, I will get only single record. Because professor name is completely dependent upon the professor ID. Now, if I give student name, will I get student ID? Or with the student ID, can I find the student name? Yes, because student name is fully dependent on the student ID. There is no partial dependencies. Okay. Here in this case, if I give only Sushmita, so will I be getting, if I give only Raj Reddy, will I be getting the student name? No, I would get multiple names. So this is nothing but partial dependency. Professor name is not fully dependent upon the student ID. So that's the reason why we moved out the professor details to a different table named professor details, and student information to a student details table from the TBL table named TBL. So now this is said to be in second normal form. What is the rule for second normal form? A table is said to be in second normal form if it is in 1NF and no partial dependency. There is no partial dependency. All the non-key columns are fully dependent on the table. This is the non-key column and this is the key column in this table. This is the key column and this is the non-key column. This non-key column is fully dependent on this key column. This non-key column is fully dependent on this column. Now this is said to be 2NF. Let's move on to 3NF. What is 3NF? Okay, and see. So suppose we have got a table named student, and in the student table, what is that we have got? We have got student ID, student name, student state, student country, and student age. So student, if with the student ID, student name is purely dependent on student ID, right? Student state is also dependent on student ID. Student country, is it fully dependent on student ID? Student age is fully dependent on student ID, okay? But what about the student country? Is it fully dependent on student ID? No. If I say Telangana, where is Telangana? It is in the India. It is in the country India. So I can also derive this. I can also find. I can also this student country is not fully dependent on student ID again here. It is partially dependent. It is transitively. We can get student state from student ID, but again we can get student country from student ID. What is that it is happening? See, for better understanding, I'll do this. Okay. This we can get this. We can't if A is related to B and B is related to C, A is somehow related to C. This is transitive dependency. These are the common columns. If you see, these are the common columns. Student state we can derive student state from student ID, but we cannot derive student country is not completely fully dependent on student ID. It is partially dependent on student ID, and it is fully dependent on student state. If at all I come up with the student state, I would obviously know the student country. Delhi, where is Delhi? It is in India. Where is Bihar? It is in India. Where is Telangana? It is in India. So student country can be derived from student state as well. So this is called transitive dependency. Okay, what is transitive dependency? If student age is related to student state and student state is related to student country, so somehow student ID is related to student country. That such transitive dependency needs to be rolled out, should be moved out from the table. So what can I do over here? So the output should be something like this. I mean, we need to take this out. Student country, delete. So okay, and then it should be in a separate table. Okay, now all these are directly dependent on student ID and student country is dependent on student state. Does it make sense now? There is no transitive dependency. Can you find any other column in this student table? Okay, which is not directly dependent on student ID. There is no such column now. Likewise, student country is purely dependent on student state. So this is what we are doing in 3NF. So 1NF, no multiple values in a single cell. In 2NF, no partial dependency. Okay. In 3NF, no transitive dependency. So see, this is what we have got in 3NF. So the table looks something like this. So I'm stopping this normalization topic right here as of now. I would we'll have a smaller session on BCNF, 4NF, 5NF, and 6NF. I don't want you to get confused. Just I would come up with some examples wherein you can work a lot and you better understand the normalization forms, as these are very important in interview point of view. So I'm stopping it here. BCNF, 4NF, 5NF, and 6NF will be covered in a different session. We'll have that session soon. Thank you. That's all for today.